Okay, we're going to go ahead and solve a couple of different questions using geometric series. So with this one in particular, the way we're going to do it is we are going to solve using the systems of equations. So before we go ahead and solve this, we need to make sure that we write down what the explicit rule is. And the explicit rule is just a to the n is equal to a1 times r to the n minus 1. So you have to have two terms in order to do this. So we're going to go ahead and take our first term, a3, and we are going to say that a3 is equal to 1/2, which we know, and then we also know it is equal to a sub 1 times r, and remember, this is n is equal to 3, so r is to the 3 minus 1 power, or I can say that, so that will go ahead and give me my first equation, which is that 1/2 is equal to a1 times r to the second power. Now I'm going to go ahead and do the same thing, but this time we're going to go ahead and do it for a5. So I know that a5 is equal to 9 over 2. This does tell me again that n is equal to 5. I also know that n over 2 is equal to a1 times r to the n minus 1 power, or 5 minus 1. So then my second equation here is that I have 9 over 2 is equal to a1 times r to the 4th. So what I have here is these two equations. I have to solve one for a1, so I'm going to go ahead and take my first equation and solve for a1. I go ahead and do that by dividing both sides by r squared, and I get the fact that I have a1 is equal to 1 over 2 times r squared. Once I have that, I take, that's a1, that gets plugged in up over here. So now I go ahead and finish solving that, and that gives me that I have 9 over 2 is equal to 1 over 2r squared times r to the 4th. Let's just go ahead and simplify that a little bit. That's 9 over 2 is equal to r to the 4th over 2r squared. Now that goes ahead and gives me 9 over 2 is equal to r squared over 2. Those 2's just cancel out, which leaves me as 9 is equal to r squared, or r is equal to, in this case, 3. I know it's not a negative 3 because it's not an alternating positive negative series, so I just go ahead and leave it as r is equal to 3. Once I have that, I go back up to my equation here to find out what a1 is. So a1 is equal to 1 over 2 times 3 squared, or a1 is equal to 1 over 2 times 9, or 1 over 18. So that was a lot there, so I want to make sure I go through and double check this, make sure we're right. So let's just go ahead and check. So the general formula, the explicit formula is a to the n is equal to a1 times r to the n minus 1. So we're going to go ahead and do this when n is equal to 3, because that was the first term that we had. And we know that a3 should equal 1/2. So let's check it. So a3 should equal a1, which is 1 over 18. And multiply that times r to the 3 minus 1 power, 1 over 18 times, I need to write that 3 in there, r goes into 3, and that gives me 3 squared, 1 over 18 times 9, which is definitely equal to my 1/2. So I know everything works. All right, so what term is the first to exceed a given number? So if I'm giving a series of numbers, so if I have the geometric sequence 1, 3, 9, 27, I want to know what term is the first to exceed 7,000. Now, let's go ahead and label them. So this would be A1, A2, A3, A4. So the first thing you need to do is be able to break the explicit rule with this. So in order to do that, we find our ratio. Our ratio is 3 over 1, or our ratio is just 3. A1, we already listed it, is 1. So our explicit formula is that AN is equal to 1 times 3 to the n minus 1, or just 3 to the n minus 1. So what we actually want to know is this. We want to know, when is 3 to the n minus 1 greater than 7,000? Now, we haven't done this in a while, but what we have to do is we have the variable as an exponent. So this, in order to solve this exponential equation, you have to use logs. So I want to go ahead and rewrite this as log, and I'm going to use log base 3 of 3 to the n minus 1. That must be greater than log base 3 of 7,000. The properties of logs, take that n minus 1 and come out. And the other property of logs is log b of b, where the base in that exponent is the same, is always equal to 1. So on this side of the equation, I have n minus 1 must be greater than log base 3 of 7,000, or n must be greater than 1 plus log base 3 of 7,000. Now we need our calculators for that. So if you have a calculator that will go ahead and put log base 3 of 7,000 in, that's fine. You may need the change of base formula, which says that's log of, or natural log of 7,000 divided by the natural log of 3. And you will get the fact that n must be greater than 9.05. Now, I do want to go through and check this. So I need to check this. So I'm going to minimize this and we can go ahead and do our check with all of this work. So let's double check. Our explicit formula was over here, which was just 3 to the n minus 1. So let's just check it. So when I have a sub 9, which is the 9th term, that would mean 3 to the 9 minus 1, or 3 to the 8th, which is equal to 6,561. The next term would be A10, which would be 3 to the 10 minus 1, or 3 to the 9th, which definitely exceeds that 7,000 at 19,683.